Hey everyone. In this video, we're going to be coding the trapezoid rule in Python. Let's briefly recall what the trapezoid rule is. The trapezoid rule is a numerical method that allows us to approximate a definite integral. This is one of the simpler forms of numerical integration in which we build trapezoids under our curve, add the areas of the trapezoids together, and that allows us to approximate definite integrals. This schematic here should make this more clear. I'm going to be coding this in PyCharm, which is a free, downloadable, integrated design environment. Let's begin by creating a new project. Then, we need to import our relevant Python libraries. As we are going to both be approximating the definite integral and graphing our function, we are going to need two Python libraries. We need NumPy and Matplotlib. Let's come to our interpreter in the bottom right here. As you can see, it says trapezoid rule, as that is what we created initially. Let's click this and then click Interpreter Settings. This is very important, as if you pick the wrong interpreter, the Python file that we are working in will not recognize the packages that we are going to download. You can change your interpreter up at the top here. Once you have the right interpreter selected, let's click this small plus sign down here, and we will search for NumPy, select it, and install the package. Then, we will repeat the same thing for Matplotlib. Now that all of our relevant Python packages are installed, let's close this window. We now need to import the packages that we just downloaded. Let's type in import numpy as np and import matplotlib.pyplot as plt. Next, we need to create two function definitions. One for our function that we are approximating the integral for, and another optional function for the second derivative of that function, if you wish to find the maximum error. Both of these functions will take in some value, x, and return the result of our function. Let's now list some of our function parameters. We have our lower integration bound a, our upper integration bound b, and our number of equally spaced subintervals, n. Then, let's make this formula here for our total integrating distance over our number of subintervals to find our step size dx. In order to plot our function using Matplotlib, we need to create values for it to plot. To do this, I'm going to make a variable called x, which we will use NumPy's linspace method that simply creates a 1D matrix of n plus 1 sections from A to B. We use n plus 1 here as our number of inputs needed is always going to be one more than a number of subsections. Then, to find the outputs at all these values, all we need to do is call our function from earlier with the 1D matrix, x, as our input variable. We're now ready to create the trapezoid rule. As we learned in our trapezoid rule theory video, our trapezoid rule is easy to implement. Let's create a variable called trapeArea. For equal step sizes, the trapezoid rule is our step size divided by 2, all times our first output value, plus all of our interior data points times 2. This sum term is just summing up all of the values in our 1D Y matrix from after the first position up to, but not including, our final position. Then lastly, plus our final exterior output value. Let's just go ahead and print the result of this. With these conditions, it should give us 15.6, as we learned when we solved this problem by hand in a previous video. Next, let's add in a way of calculating the maximum error of our trapezoid area. This section will be finding the maximum second derivative of our function. That will then be plugged into the following formula. Our 1D matrix of x2 prime here is just saying that within the bounds a to b, create an arbitrary amount of inputs. I just put n times 100. The more points created here, the more accurate your answer will be, with the trade-off of slightly longer runtimes. Printing the maximum error, you can see that with more subintervals, our maximum possible error decreases as we would expect. At this point, we are essentially done with finding our trapezoid rule and the associated maximum error. I'm going to add a small f print statement that returns our results found. Lastly, I'm just going to add a couple lines of matplotlib to print out a graph with markers to demonstrate our trapezoid rule. Now, graphically, increasing our number of subintervals, you can see that with more subintervals, we better approximate our definite integral. Additionally, if you want to visualize more of the function on your matplotlib graph, you can add this small bit of code that will simply evaluate our function for some more inputs outside of our two previously defined boundaries. Recall that this final linspace parameter is simply our number of inputs evaluated, so too few and our graph will look non-smooth. Lastly, this later line will add it to our plot. Changing our input bounds will just show you more of the underlying function. And there we go. We have just coded a very simple trapezoid rule Python code that can approximate a definite integral using the trapezoid rule, find the trapezoid rule maximum area, and provide you with a simple graph visualizing the function and the trapezoid rule. I will say this is not the most intricate or concise trapezoid rule code. I just wanted to ensure that it was simple and easy to read above all else. I hope that this video helped your understanding of how to code the trapezoid rule within Python. If you enjoyed, please like, subscribe, and consider checking out our YouTube memberships by clicking that join button down below. However, if you have any comments, questions, or concerns about the information I provided in this video, please leave a comment down below and I will do my best to address your concerns.